Hello. Hello. Good morning.
Hey, hi. Good evening, Mijanur.
Yeah, good.
Can you admit Sachin?
Okay, no, he not joined yet.
He said he's waiting in the
Okay, so but there is nothing in your notification. Okay.
which link he's using.
Right. He did not join yet.
Hmm. I messaged him not responding to that. Let's keep calculation and concern about overlap of India. Hmm. Yeah, that's true.
Okay, he joined.
Okay.
Okay, so
Hey,
good
good morning,
morning.
Sajid.
Hey, good morning. Yeah.
Okay. Okay, so now we'll start
Okay.
our today's session. Okay, and I also start the recorded. Okay, so let's go. Mm,
माझा कॉल चालू आहे. एरिच.
okay, so now can you see my screen?
Yes, yes, it is coming up.
Hmm. Okay, so basically today is our second days of online training program, and we also try to complete all of the rest of the part which is not completed. Okay, so let's go. So first of all, I will try to discuss about the part how we can easily filtering and displaying the satellite images in Landsat and Sentinel satellite imagery. How we can easily filtering and displaying, and also download the satellite image from the Google Earth Engine platform. Okay, so basically, Landsat Sentinel both of image we can easily get from the satellite. Okay, Landsat is the 30-meter resolution and Sentinel is the 12-meter, 10 to 12-meter resolution. Okay, so let's go. Then how can you use the different types of band combination, such as true color band composition, combination, then false color band composition. Okay, how you can easily create that, we also try to discuss. And how to export satellite imagery from the Google Earth Engine platform. How we can easily export the satellite imagery, we also try to discuss. And how to import, filter, clip, reduce, and display the data in Google Earth Engine platform. And how to make the time series chart of the NDVI. Then how to export any shapefile from Google Earth Engine platform, and how to calculate any indices from the satellite images. Okay, so let's go. So Earth Engine public data catalog. So in this Earth Engine public data catalog, we can easily access.
Just one quick question, Janur. So,
Yeah.
Sachin, you know what is shapefile?
No.
Okay, shapefile is the format of the file that is being used into the ArcGIS. The ArcGIS is it's a platform, GIS-based platform,
Mm-hmm.
or the tool, right? So that is being heavily used into the industry from the GIS purpose, right? So that's what the shape and shapefile is the format. Basically, it has either vector data mostly,
Mm-hmm.
can be all sort of point line polygons, roads, networks, and all those things. But it can also store the images.
Okay.
Yeah.
Okay, sorry,
Yeah.
Amijanu, please go ahead.
Okay. Okay. So now Earth Engine public data catalog. In this public data catalog, we can easily access all of those satellite imagery. Okay, such as Landsat, Sentinel, Modis, different types of train data set, land cover data set, different types of atmospheric data set, we can easily access from this Earth Engine public data catalog. And this
Mm-hmm.
public data catalog daily updating. Okay, and here we can find out the more than 200 public data set, more than 4,000 new images for every single day, more than 5 million images, more than 5 petabytes of data or more on the way. Lot of data so we can easily access from this Earth Engine public data catalog. And this is the link for that. When you can simply go to this link, this data set will be appeared. Okay. So in this time, I simply open this Earth Engine code editor. You can see in this code editor, when I click on the browse data catalog, it automatically open this Earth Engine public data catalog page. Okay, here you can see a lot of data so you can easily get. So at this you can see the surface temperature data set, climate data set, also you can see the atmospheric data set, weather data set, also different types of imagery, Landsat, Sentinel, as well as also you can see the Modis high resolution imagery. Also you can see the geophysical data set, train data set, land cover data set, proplan data set, other geophysical data we can easily access from here. Not only for that, you can see first of all, I try to discuss about the Landsat image. You can see the Landsat image, mainly the Landsat image, we can get this image from the year of 1972. Okay, basically we can get the image for the Landsat year of 1972. Okay, for the Landsat, only give you the satellite image this time from this time period. At the present time period, we can also get. And Landsat image also have some division or category, such as you can see Landsat 9, Landsat 8, Landsat 7, Landsat 4, 5, Landsat 4, Landsat 1 to 5. So basically, it's depend on the time period. Suppose you can see Landsat 9, we can get for the year of 2021 to present time, we can get Landsat 9 image. We can get the Landsat 8 year of 2013 to present time, Landsat 8. Also Landsat 7, we can get the Landsat 7 1999 from 2021. Also you can see the Landsat 5, we can get the 1984 2012 Landsat 5. Landsat 4 TM from 1982 1993. Between this time we can get the Landsat 4 TM. Also you can see Landsat 1 to 5 MS, we can get the 1972 from 1999. Okay, so basically we can get the satellite Landsat image from the different division. Okay, suppose in this time I need this for this time period I need this satellite image between this time period, so I use that. So I need this time period between this that, so I use that. Okay, and this Landsat image day by day also developed. Okay, so new different types of band. So basically satellite image is the combination of the different types of band. You can check the satellite image. Suppose I simply open one satellite image. Basically this satellite image we can also divide it. Some other thing is that you can see the surface reflecting satellite images, top of atmospheric satellite images, raw image. Okay, so surface reflecting satellite image, top of atmospheric satellite image, raw image. So basically all of the satellite images for filtering process is the same, but when you want to work, suppose you want to make the land use land cover classification map, then the surface reflected satellite image is the better. You want to identify only for the different types of indices such as NDVI, NDWI, then this satellite image is better. Okay, and surface reflectance and top of atmospheric, suppose I simply open that surface reflectance, you can get, this is the band, all of those band, this the total all of the band we can get for the surface reflecting satellite images, total 7 band from 1 to 7 band. Okay, this is the total surface reflectance band. Okay, as well as you can also get the description about the satellite images. So mainly this data set contain the atmospherically corrected surface reflectance. So this data set is the already atmospherically corrected. Okay, so that's why in this time when you are using this platform, then you don't need to use the atmospheric correction, because it already contain this data set the atmospherically corrected, and surface reflectance also correction already done, and land surface temperature derived from the data provided by the Landsat 8 sensor. Okay, then we can get the content the 5 visible and near infrared band in here, and also get the 2 short wave infrared band, short wave infrared 1 and short wave infrared 2 we can get also from this here. And it's mainly orthographic surface reflectance and 1 thermal infrared band process to the, we can get this surface temperature also. Okay, so basically this band also contain the intermediate band also in here, and it calculation of the ST product as well as also QA bands. Okay, so different types of band in here, and we are using here the different types of band for our different types of work. Suppose when we want to work with the land surface temperature, then you also need to work for the other types of band, such as we need to work for the brightness temperature band or band 10. Okay, so we also try to discuss all of the things step by step, then it also clear idea you can get. So in this time you just remember that satellite image mainly the combination of the different types of band. You can see this type of band: B1, B2, B3, B4, B5, B6 and B7, and this band depend on the wavelength. Okay, it's depend on the wavelength. Suppose from the sensor reflected on the surface, then we can get the some wavelength, and from this wavelength it create this some specific, for the specific band create some specific wavelength, and then we are using here the different types of wavelength band combination, and we can easily get the result. We can get the different types of natural color composite, false color composite. Okay, so let's say about that we try to discuss about the practically, then it also better. So in this time, suppose I want to work with this image collection, Landsat 8 surface reflectance image collection, I want to work with that. Okay, and you can see the Landsat 8 image, what is the availability date from 2013 to 2023 0604, and also mention the time within this time we can get these satellite images. You can see dataset provided is that USGS. And what is the USGS? If you want to know about that, simply click on here. So mainly USGS is provided the different types of Landsat imagery. You can see Landsat collection, to label, to science product. Okay, just we are waiting 1 minute because the out noise is coming in here. Just waiting for the 1 minute. Okay, sorry for that. Actually, here the election will be happen on the 21
Yeah,
June.
okay.
So that's why all time they are the miking or other things for the air. Okay, okay. So let's go. Okay. So now you can see here USGS. So mainly USGS provide you the Landsat collection, Landsat image collection you can get from here. Okay, and in the meantime you can see. Okay, so you also try to read this article, then you also get the better idea about that Landsat 8 image collection. All of this information you can easily get. So I also send you the link for the Landsat 8 image collection. You can get the better idea about that. Okay, and we can get all of the things from here. You can see the Landsat 8 collection to top of atmospheric reflectors image Landsat 2. Okay, so basically you can see top of atmospheric image collection, surface reflectors image collection, and surface temperature. Okay, both of things we can get from this image collection, as well as level 2. Okay, basically they are also discuss about the process of this image collection. Also you can see QA pixel band. Okay, mainly it is the quality band. Okay,
Mm-hmm.
also surface temperature, different types of metadata you also try to discuss about that. Okay, so in this time, suppose I want to work with this image collection. First of all, what can I do? First of all, I need to import this image collection in my code editor. So this is my code editor. This code editor, I need to import this image collection. So how I can import? Just I simply copy this ID. So basically this is the ID. Simply copy that and paste here. Okay, and give a variable name. Suppose I put the variable name is that you can use any name. So I put the name, suppose L8. Okay, so now my data set is the imported in my code editor. Okay, so now if you want to check it, how many emails are available for the whole world? For the whole world, how many emails are available? I want to check it. How much number? So for that, simply use the print function, and then call the L8 and use the function size function. Okay, now click to the run. In this time, it calculating how much image is available for the Landsat 8 surface reflectance between the time period year of 2013 to present time for the whole world. How much image is available? We try to check it. So now it's computing the result. Okay. So that you can see here, you can get the very large number of image collection. You can see very large number of image collection we can get in here. Okay, and this large number of image collection for the whole world. Okay, for the whole world. And what is the time period? This time period is that year of 2013 to present time. Okay, and mainly now we need to filter this large number of image collection. Okay, so this large number of image collection I need to filter. So now how I can filter this image collection? Okay. So basically when you want to filter this image collection, filtering is depend on the three factor. First factor is that where. Second factor is that how. And third factor is that when. Okay. So where, how, when. According to these three question, we filtered the large number of image collection. Okay. So in this time, I can get large number of image collection look like that, but it for the whole world, but I don't need for the whole world. I need this image only for the specific boundary of Dhaka city. Suppose I need this satellite image for the Dhaka city. Okay. So for that, what can I do? I just simply imported the Dhaka city boundary shape file. Or which area you want to need this satellite image, you can simply import your boundary shape file. Okay. So if the question is for where, okay, where you need the satellite image, I need the satellite image for the Dhaka city. So just I simply import that Dhaka city boundary and give the name, suppose ROI. You can use any name as the variable ROI. So now what happened, you can see, I take a variable. Suppose I put the variable name is that filter area. Okay. I got total large number of image collection for L8. So I simply copy the L8. It stored total more than 1 million satellite images for the whole world. But in this time, I don't need for the whole world. I need only for the Dhaka city region. Okay. And Dhaka city region shapefile stored the ROI. Okay. In this time, I need to use a function. This function called the filter bounds function. Okay. So mainly filter bounds is a function. It intersecting with your whole image collection with your region of interest. In this time, suppose I can get the 1 million images in here, but it's for the whole world. I don't need for the whole world. I need only for my region of Dhaka city. So that's why I simply use the filter bounds and put here the Dhaka city boundary shapefile variable name. You can see Dhaka city boundary shapefile variable name is that ROI. Okay. Just I simply use here the ROI. Okay. Now let's check how many images are available for the Dhaka city region. Just simply use here the print function. So print and call the filter area and paste here and use here the size function and click to the run. In this time, I can get the result only for my Dhaka city region. How much image is available? Here I find out total 410 images. Okay. So 410 images is available for my region. Okay. So now from 410 images, I want to need only for those images, which image will be not more than 1% cloud cover. Okay, suppose in this 10 parts, 410 images, it can be different types of cloud pixel value, but I need only for those images, which image will be not more than 1% cloud cover. Okay, so let's go about that. So for that, I take the another variable. Suppose filter metadata. So I simply, you can use any variable name from 410 images. Okay, 410 images stored in this variable filter area. I simply call that and paste here and use the function filter metadata. Okay, and what is the metadata? The metadata mainly image properties. Image properties, you can get the image properties from here. You can see the image properties. In this time, I want to use here the cloud cover. Okay, so I simply copy the cloud cover because I need the less than 1% cloud cover image. So simply copy the cloud cover and paste here the cloud cover and set the operator. Operator mainly I put the operator less than and set the value for 1. Okay. Now let's check how many images are available for my region of interest in Dhaka city less than 1% cloud cover. So for that, simply use the print function and call the filter metadata. Simply copy that and use the size function and click to the run. I can get only for the 61 images are available for my Dhaka city.
Okay, from filter area object, you have extracted filter metadata, right?
Yeah, filter metadata mainly provide you how you can filter. In this time, I want to filter. I need only for the less than 1% cloud cover image. Actually, it's a very less 1%.
Right,
It
you are
can, yeah,
expecting that. Okay.
yeah. Okay. So now you can see I can get 61 images are available for my region, which are less than 1%. If you want to check how many images for the 5% cloud cover, then this number is also increased. You can see 107. But I choose less than 1% because I need to, my main target is that good quality image. How I can get the very good quality image without any cloud, without any cloud shadow. Okay. So I want to choose here the 1%, less than 1%. I get total 61 images. Okay. And this 61 images, what is the time duration? This time duration is that year of 2013 to present time 2023 0604. But I need this image for a specific time period, not for the whole time period. I need for the specific time period. So when you want to filter that, so now I want to use for the when this satellite image I want to need. So I simply take a variable, suppose filter date. I get total 61 images, but from these 61 images, I want to need only for those images which images are available for year of 2021 or 2020. For that, I use the filter date function and put here the start date and end date. So simply put here the start date, suppose 2020, 1st January from 2020, December 31. Okay. Now click to the run. And then I want to check how many images are available for this year. So I simply copy and put here the filter date and use here the size function. And now click to the run. Now you can say I can get only for the 5 images for my region, for my specific time period. Okay. So first of all, you can see when I want to print this result, whole image collection, I print that how many images are available. Here I can go total more than 1 million images for the whole world. Okay. This image I want to filter according to the question where, then how, and when. And where means that your area. Where you need this satellite image. I need this satellite image for the Dhaka city. So I import the Dhaka city boundary shapefile and use the filter bounds function and put here the shapefile variable name. Okay. I get total 410 images for my Dhaka city. Okay. Then how? From 10 and from 410 images, I want to need only for this image, which image is the less than 1% cloud covered. Okay. I can get total 61 images. Okay. Then from 61 images, I need for the specific time period. Suppose I need the image only for the year of 2020. So that's why I simply call the filter metadata, because this variable stored the 61 images. Okay. So I call the filter metadata and use the filter date function and put here the start date and end date. Then finally I check it only for the 5 images for my region. Okay. So first of all, I can get the result. You can see, can I use the different types of question and I can get the very small size of this image. So it's the filtering process. Filter bounds is a one function, mainly filter bounds in the intersecting with your image collection only for your region of interest. Filter metadata, mainly this function, filter image properties. I want to use the cloud cover image properties. Filter date, mainly filter a specific time period. Okay. So using the filter bounds, filter metadata and filter date, we are filtering our large number of image collection and get very small number of images only for the 5 images for my region. Okay, so now any question for that you can ask me, any doubt or any confusion about that.
No.
Okay,
So,
in this,
Mijan,
yeah,
also one quick question here. So we filter 5 images right now, right? So all of them are of the same resolution, right? Because that's the Landsat 8. And all these images will have all the bands into it.
Yes, all of those band for the Landsat 8 we are getting in
Okay.
here, because in this time we are not selecting any band. So in this time, this 5 images. Okay, so now let's check about that. In this time I can get 5 images. Okay, and this 5 images is not captured by satellite at the same time of the year. The year of 2020, this 5 images is the captured the different time of the year. Okay, so now let's check about the time, about the specific date of the acquisition time period of this total 5 images. So let's check about that. We check it. So for that, just simply use here the print function and call the filter date. Simply copy that and paste and click to the run. So now I can get all of the information about this image collection. Here you can see I can get total 5 images. So simply click on here, and then I simply go to the feature. You can see in this time. So image one, it acquisition time is that year of 2020, 11th February. Total band 19 band on this image. Also you can see second image, year of 2020, 26 January, 19 bands. Also you can see year of 2020, 11th February, 19 bands. 2020, 30 March, 19 bands. 27 December, 19 bands. Here I can get all of this image time. Okay, so in this time, suppose in this time you want to work for the specific
So,
date image you want to work.
with this filter criteria, with less than 1%
Yeah,
cloud cover, it is clear that in Dhaka during winters your clouds are clear, right? It's mainly the December to December, Jan, Feb, and max by March, and that also on specific days, not on all days.
yes. So
Yeah,
basically,
for that year.
yeah, for this, suppose in this time here I can get the image, this image according to my condition. But when I increase the value for the less than 5% or 10%, then this image is also increasing, this image value is also increasing. Okay, in this
Yeah,
time
yeah,
which image I want to get
that
in
is
here,
clear.
all of this image is less than 1% cloud cover.
Yeah, less than 1% means almost nothing, right? There are no clouds on the
Yeah,
in the sky.
yeah,
So that means those days were clear sky day, right? Sunny days.
yeah.
And that stuff, if you see the dates, especially from the 2020 standpoint, right? So if you see the dates, so they are mainly into the winter,
Yes,
December to March.
yeah.
That's the conclusion. That's kind of a, if we can even compare this with the different years for 2020, 2021, 20, all those years, and see whether this is same trend. May not be the same dates, but same trend.
Okay, so actually your voice is very slow. I did not hear you something about that.
I was saying if we compare that with the different years, 21, 22, then in that case we will see, we'll get those clear or less than 1% cloud coverage images mainly into the winter time for all those years. Then we will find out what are those dates may not be same, but still number could be same.
Yes.
Maybe 21 you will have 780 days clear sky in 22. Why I'm saying this? So clear sky means there are no cloud. So from the environment standpoint, we can imagine like that's a winter time, and if we have to do some environment related, weather related analysis, so this kind of analysis we can use.
Yes, it also possible. Yeah, it is
Yeah,
possible.
yeah. Okay,
Yes.
sorry, we'll go
Oh,
ahead.
okay. Okay. So now I want to display the result. Suppose I want to display the result about this image, year of 2020, 11th February. This image I want to show on my map. So what can I do? I just simply click on here, and you can see it provide me the ID. Okay, just I simply copy the ID of this image. Simply copy, and then I use a function e dot image image and put here. Okay, and give a variable name. Suppose put the variable name is that image. Okay, now let's check about this image. We want to display the image as the layer, so put here the map dot add layer function and call the image and click the run. You can see one layer will be added. I also need to focus my center of the boundary shape file. Use at the map dot center object and put object is the ROI. Suppose put here the 10 and click the run. So now it automatically focusing. Okay. So now again I can get this image in here as the tiles. Okay, and this tiles default it's showing look like that. Okay, in this time suppose I want to use the band combination such as this is the red band, then green band, and also blue band, or it's called the RGB or natural color, red, green, and blue. And then stress 98% for better looking, and then apply. Then I can get the image look like that. Okay, as the tiles. Okay, basically this tiles creation time is that. What is the time? You can see this time is that 11th February. Okay, 11th February. This is the creation time.
Can you means reduce the zoom scale? Maybe make it 10, 15 or something, so that
Yeah. So it's not possible
through the
using the pen sharpening
yeah,
technique. We can also do that. Okay, so I'll also try
yeah,
to
yeah,
show later about that for how can easily increasing the resolution using the pen sharpening technique.
yeah.
Okay, so now you can see here we can get these tiles. Okay, so basically these tiles acquisition time period is that 12 February. Okay, year of 2020. In this time, I can get these tiles, but I need the result. Suppose in this time you can easily put your shape file in for this region and click with that. But I need the result for the Dhaka city. Okay, I need the result for the Dhaka city. Now I want to check my Dhaka city area is fully covered these tiles or not. I want to check it. So let's go how we can easily check it. So for that I need to simply display the result of the I also add a layer about the shape file. So use at the map dot add layer and call the shape file is that ROI. Okay, so now click to the run. In this time my shape file boundary is also added, and now I want to check it this tiles is fully covered or not. You can see this tiles is not covered my region. Okay, it some part is missing. You can see this part is not fully covered. Okay, in this time I change the image collection or image and try to check the another tiles. So I need to check the another tiles is covered or not. Click on here and then simply copy this ID 26th of January. I have to check this image. What is the condition about that? Just simply change in here and paste and click to the run. So now we check about this result. Okay, so this tiles is fully covered my region. You can see this region is fully covered my region. Okay, this tiles is fully cover my region. So now I can easily use this image. So for that, what can I do? This is my image, full image collection. I just clip with my shapefile. Okay, for clip. So just I can simply use that the clip function. Clip with my shapefile is that ROI. Now click to the run. So now I can get the result only for my boundary of Dhaka city. Okay, it's the default showing look like that. I want to set the visualization. Suppose I want to set the visualization for that red band. Before is the red band. Then also set the red, then green and blue. And also stress the reflectance such as 98% for the better looking and apply that. So now I can get the image look like that. You can see. And its image is the Landsat 8 image collection. And this image is the surface reflectance image collection. Okay. So now we can, if you want, you can use this image collection for your classification Suppose you want to classify the build-up area, then water body, then also vegetation. Suppose also you can see the barren land. Okay, we can easily classify it and also make the lot of remote sensing work, such as make the NDVI or NDWI, different types of indices. We can easily do that. Okay, so this is our satellite images we can get for this region. Okay, and in this time you can see I also need to import that this visualization. I need to import in my code editor. So just I simply import, you can see import. When I click the import, a new line of code will be added in here. You can see will be added in here. Just I simply copy the variable name from here and paste after the object name. So paste after the object is that image, and put here this object and simply put in here, and then click to the run. So now this image visualization is a set with my code editor. Okay, and I get the result about this. So now using this same code, you can easily get the image for the any region. Suppose I simply change my area of interest. Suppose in this time I want to need this satellite image for the region of okay, so I simply change the region. Suppose I need this region for another region. I simply import the another boundary shape file, and using the same code I can easily get this result. So for that I also provide you all of this practice code also. So you also try to check it for your own region. Also import your own boundary shape file and also check the result. Okay, suppose Delhi listed area. Just I simply import that, and just you can see Delhi listed area. I simply remove my previous shapefile and put the shapefile name is the ROI. ROI. So now I check the result about this. So click the run. So now I can get this satellite image for the Delhi listed area. Okay, in this time I also need to do another thing is that I need to change the image collection, because this time is okay for the Dhaka city, but in this time is not okay for the Delhi. Okay, so now we want to check the image collection. You can see here we can get total 17 images. So that's why you can see the 17 images we can get in here. 17 images, 17 tiles. So I want to check it. Suppose these tiles about the result. Simply copy and paste and click the run. Okay, so you can get this salary. You can see easily we can get for the surface different salary image about this region. And now you can easily use this image for making the different types of remote sensing work. In this image, we have also get the another problem. You can see this image is not covered. This part you can see this part is not covered. Okay, so in this time, if you want, you can check the another image, then check about these tiles. Is it fully cover your region or not? Okay, but we are also applying the another method. Suppose when you want to work with for the whole country boundary of India, suppose you want to need this array image for the whole country boundary of India, then one tiles is not possible. One tile is not covered the full boundary of India, or you want to need this serrated image for the full country boundary of Bangladesh, then one tiles is not possible for the whole cover the full country boundary of Bangladesh. Then we also need to apply the another method. This method is that median composite. Median composite mainly that suppose I can get total 17 images. I use all of those images and create the median image. Okay, then it fully cover my region. In this time, I use it only for the single image or single tiles. But single tiles is not cover the full region at the same time. Suppose I need this satellite image for the whole country boundary of Bangladesh. So Bangladesh is not covered for the only for the one tiles, is not covered for the full boundary of Bangladesh. So then I also need to apply the median concept. So I create the median composite from all of those images. Then it will be cover my region. Okay, so let's go about that. How can easily create the median composite? And this process is for single image collection. When you want to need only for the single image time period image, then apply this work. Okay. Sometimes you also need to work for the median composite. So for that, what can we do? So take a variable. Suppose I put the variable name is that final image. And from these 17 images, I want to create the median composite. So for that, what can I do? Just simply put here that and call this filter date because it stored that 17 images and paste here and use a function median function. Okay, put here the median. So now it calculated the median composite. Okay, so now display the result. So use at the map dot add layer and put here this final image. Okay, then click to the run. So in this time, it display the about the result about that median composite, and this composite create from the total 17 images. Okay, you can see in this time it fully cover my region and all of the styles connect and make the median composite. So when you want to work for this, you can see, suppose we can get total 17 tiles for this region. So in this time, all of those tiles create the median composite. Okay. So then it easily fill up my boundary, also cover my boundary. So just I simply clip with my shapefile. So clip with my shapefile is that ROI. Then click to the run. So now I get the result only for this boundary area.
So just to add one thing, Sachin, for you here, this you can imagine, right? So there are like it's a small region in India, like Delhi, and you have 17 images from different dates, right?
Mm-hmm.
For that region, and then we are creating a median image out of it. So you can
Oh,
imagine the power required because these images are maybe at least in GBs for the small region, right?
Yeah.
correct.
Or if it is a large region, they will be in the TBs. So you can imagine, and this kind of a operation is difficult to perform into the typical GIS applications. So that's the
Okay.
power of the Google Earth engine, and that's the power of Google Cloud.
Yes.
And
Okay.
you can see the performance also here. Of course, it will take some time because it has to process all those 17 images, create the median out of it, right? So for example, in at least in the central area, out of 17 you will at least have 5 6 10 images overlapping to each other, and then calculate the median pixel value for that each and every pixel. In certain areas like corner areas, you may not have all the 17, or you may only have one or two images, like the area that was missing in the earlier case, right? So for that you will only have 2 3 images, for example. So it
Mm-hmm.
is calculating median out of those 3 images only. So,
Mm-hmm.
so it's a that requires a power, right? And that
Google
is
Earth
surely
provides it
do
for
it.
free. Yeah, right. So,
Okay. So now you can see we can
so
easily
this
get
is
this satellite images. And so this is the process for filtering the satellite images about that. So in this time you can see here, okay, median composite you can create in here. In this time you can see for the filter bounds I take a new variable. For the filter metadata I also take a new variable. Filter date I also take a new variable. Okay, but Google Earth Engine platform you can take only for the one variable, And under this variable, you can put all of those function one by one, one by one, one by one. Okay, suppose you want to put at the filter bounds function, and also put the filter metadata function, and also put the filter date function one by one, one by one, one by one. Okay, so it is also possible. So in this time, I simply commenting all of the code and try to show you the process. So basically, in this time I add the individual variable name for the understanding. Okay, how it will be work. But when I write the code, I just simply write the code about that only for the one variable, and under this variable put all of those function. So let's go about that how it will be work. So just I simply take the variable. Suppose I put the variable name is the suppose image. Okay, and then I simply call the L8. L8 is stored my full image collection. Use at the filter bounds with ROI. Okay, and then use at another thing is that filter. Suppose filter metadata. Filter metadata. I put at the filter metadata. Suppose year of 2020 or 22. Suppose 2022. 1st January from 2022 December 31. I also put at the suppose filter. Oh, sorry, it's a filter date because I filtered the specific time period. Okay, put at the filter date and then filter metadata. I put at the metadata. Suppose cloud cover. Then put at the less than and put at the less than 1. Okay, so you can say filter. So it's called the question about my where I need this satellite images. It called the question about the when I need this satellite images. It's called the question about that how less than 1%. Okay, so all of the things I want to create the median composite. So put at the median and create the median composite and clip with my shapefile. Okay, in this time click with the ROI. Okay, in this time you can check about that. In this time all of those things stored in this variable image. Okay, all of those things, but in this time it not create the image collection. So this concept is very important because a lot of people will be mistaken this part. So in this time it's not a image collection, it's only for the single image of the median single image. Okay, it's not a image collection. When I applying the median and also applying the clip, then it will be not a image collection. Otherwise, when I put at the filter bounds, filter date and filter metadata, then it will be image collection. After applying the median, when I put the median, it means that it create only for the one composite, one median composite, or only for the one single image. Suppose you can check the result. Suppose I put at the print and I want to put at the print image. Use at the size function. Here I can get how many images you can check. It's the image collection. Okay, now which I want to get the result, it's the image collection. 23 is the image collection. But when I apply the median in this here, then it will be not a image collection. It create the only for the single image. Okay, so I also click with that and also click. In this time you can see when I apply the size function, this size function is not work. It's showing the image size is not a function because size function only for the work for the collection. But when I apply here the median, then it will be not a collection. It's a single image. It's only for the single image. Okay, so that's why in this time it's not working. So that's why when you want to apply the median and also put the clip, then this function or this variable is not a collection. This variable is only for the single image. And this single image create from the total all of those images median result. Okay, so now I simply print that image. I did not use the function, I use the image. And in this time we can get the result. We can get only for the one image. And which median image I create, this median image also contain total 19 bands. Now display the result. Simply use at the map dot add layer and call the image and also call this visualization parameter. Just copy that and paste here and click to the run. So now I can get the result about that. You can see median composite about the year of 2022 satellite image I can get in here. Okay, and now this is the process. But when you want to work with a single time period image, then you can also get the image collection look like that. You need to create the get image collection and paste here the image ID. When you want to work for the single or single time period image, then also work with that. Okay, so now we can get this satellite images. Suppose now I want to export this satellite images from here, and then also work with for the other geospatial software, ArcMap or QGIS software for different types of work. Because mainly in Google Earth Engine platform, we are not downloading the satellite images, but some tasks we also need to download. Then we also download. It's also possible to download. So mainly Google Earth Engine platform, we downloading the final output. Suppose this image I want to use for land use land cover. I want to download the final output of the land use land cover. This image I use for the land use vegetation. I want to identify where the vegetation is available. I want to identify where the water is available, where the builder is available. So this type of result we can easily extract from here. But anyone, if you need the satellite images, need to the work for the other software, then
So,
we can also download the satellite images from here also and work with the other
so
software.
Milian, on this particular area, right? So, can we see the other bands data from the
Oh
other
yeah, yeah, yeah,
bands,
yeah,
because
yeah,
this is
yeah,
RGB, right? So
yeah.
only
It's
three
RGB
bands
color.
are there.
Suppose I want to use here the other types of composite. It called the false color composite. Suppose I put here this near infrared band. Suppose this is a near infrared band. Is that okay? B5, yeah, B5, then B4, and also B2, and also 8%. So now it's called the false color composite. And this composite, mainly the red color, you can see this type of red color identify the dense vegetation. Okay, red color identify the dense vegetation, and black color identify the water body. You can see it. This is the water body. Identify the water body. When I use the pen combination, it's showing the black color. It's the water body. Okay, and this red color identify this is the dense vegetation. Okay, and this type of you can get the result. It's a build up area or settlement. Okay, this is settlement you can see. Okay, we can easily identify. Not only for that, if you want, you can use here the suppose short wave infrared one. It is the B6, and also suppose and B5, and also put here the B3.
It can be any combination, right?
Yeah, any combination you can put. There is no problem. But some
Yeah.
combination has some specific meaning, and some
Correct.
combination
That's
also
what I'm trying to
provide you with
understand.
a specific feature. We can easily find out from the satellite
Hmm.
images. Suppose you can see mainly this this combination work for that when you want to identify the cropland or identify the suppose barren land, then it also work very well. Suppose in this time, this type of brown color mainly it's identify the you can see brown color it identify the barren land or there is nothing about that. And also you can see this type of result when you can get the this type of shape or shapely it's identify the cropland. Okay, shapely you can see mainly that square or rectangle, this type of shape get the green pixel value, it's identify the cropland, and you can see the barren land
Yeah.
also you can get the cropland.
Which is the infrared band? B6, right?
It's a short
Can you go to the USGI